Yeah. So, let us continue with the last lecture. So, last class we have discussed the Thevinen's theorem. So, statement of the Thevinen's theorem, and we also solve one example problem on Thevinen's theorem. So, now this today's learning objective is to solve the networks using the Thevinen's theorem. So, coming to the statement of the Thevinen's theorem. So, Thevinen's theorem states that the open output target terminals in any network, the open output target terminals, the network with open output target terminals can be converted into only a single voltage source in series with the resistance. That is called a Thevenin equivalent circuit. That Thevenin's voltage we are calling as a open circuit voltage, and the resistance we are calling as the Thevenin resistance, that is the resistance seen from the open output terminals. So, we have solved one problem, that is the case 1, which is consisting of the network consisting of only independent sources. Now let us take this today case 2, that is the network consisting of more number of, that is the element, that is sources, that is independent sources and dependent sources. If the network consisting dependent sources, then how we have to solve the Thevenin equivalent circuit? That means how we have to draw the Thevenin equivalent circuit, and how do we have to find out the Thevenin's voltage and Thevenin's resistance. Let us see in this lecture. So, if the network has dependent sources, so we have to turn off all independent sources. So, how we have to turn off? Whether it is a voltage source, make it as short circuit, whether it is a current source, make it as open circuit to find out the Thevenin's resistance. But here, if the network consisting of dependent sources, okay, so if the network consisting of dependent sources is circuit with all independent sources are set to 0. So, we have to apply either 1 volt voltage between these across these two terminals A B, or we have to alternately we can also apply the current source, that is I naught, maybe 1 ampere current source between the across the same terminals A B. By using these two methods, we can find out the Thevenin's resistance. So, to understand this, see here linear circuit across the A and B. So, we have to find out the IL and RL. Okay. So, then we can, once you find, see if you apply the voltage source, that is a 1 volt, then the Thevenin resistance is nothing but we have to find out the current I naught. So, Thevenin resistance is, so the 1 volt by I naught. So, if you apply the current source to find out the Thevenin resistance, so that is 1 ampere current source, then we have to find out the voltage. So, that is V naught by 1 ampere will give you the Thevenin resistance across the same terminals. So, this is the, once you find the Thevenin resistance, then the current flowing through the load resistance. So, what is the element you are disconnected? So, that is load resistance, again you connect it in the circuit, and the current flowing through the circuit IL is equal to, so V by R, here V by R is nothing but R Thevenin's plus load resistance is RL. Once you find the current, then the voltage across this element by using this voltage division rule. So, VL is equal to IL into RL, that is total voltage V Thevenin's into that resistance, okay, RL by total resistance R Thevenin plus RL. So, this is the way we can find the voltage across the load resistance and current flowing through the load resistance. Now, let us solve one problem, example problem on this Thevenin's voltage of the case 2, that is a network consisting of dependent sources. Now, see this problem. So, in this network consisting of one independent sources, that is a 5 ampere current source, 5 ampere current source, and the other dependent source, that is the 2Vx. 2Vx is the voltage dependent voltage source. That means, this is the voltage source, the voltage of this source is depending upon the voltage across the 4 ohm resistor, that is Vx. Now, how we have to find the Thevenin equivalent circuit? How we have to draw the Thevenin equivalent circuit? That is the question here. So, here independent sources, dependent sources case. So, because this case 2 is a combination of independent and dependent source. So, what I told, if there is any independent sources, so we have to kill the independent sources. That means, so in this circuit, we have only one independent, that is the current source. So, we have to kill the current source, means make it open circuit. Okay. So, to find the R Thevenin's in figure A, so independent source is 0, that is current source is open circuit. So, therefore, we have to apply the 1 volt. Now, see 1 volt voltage source across the terminals A B, okay, and we have to find out the Thevenin resistance. Now, see this is what the circuit here, see. So, now I have open circuited this current source, I open circuited current source, therefore, I have eliminated the kill the source. Now, only this is circuit. Now, apply the 1 volt source, okay, 1 volt voltage source across the AB terminals. Now, first to apply the Kirchhoff voltage law in the mesh 1, that is let us I am using here mesh analysis principle. So, let us assume the all the currents are in clockwise. So, in the first loop, so that is the mesh 1 is I1 current, in the mesh 2 that is loop 2 is I2 current, and mesh 3 is I3 current. So, now apply the Kirchhoff voltage law in the first loop, okay. So, therefore, I am starting at this minus step point, okay. So, minus 2 Vx, the first equation, minus 2 Vx plus the voltage drop in the 2 ohm resistor. So, this element is connected between the two meshes, mesh 1 and mesh 2. So, 2 into current I1 is entering, whereas the current I2 is leaving, therefore, 2 into I1 minus I2, which is equal to 0. So, the algebraic sum of the voltages around any closed path is equal to 0. So, if you take the 2 common and send to the RHS side, becomes 0, therefore, you will get the Vx is equal to I1 minus I2, first equation. But what is the Vx value? The voltage across the 4 ohm resistor here, nothing but the according to the Ohm's law, the voltage across any resistor is equal to the product of the current flowing through the resistor and the resistance. So, therefore, here Vx is equal to minus 4, see minus 4 into I, because current is coming in the clockwise direction, but the voltage polarity is plus minus. Therefore, minus 4 into I, that is I2, sorry, here you replace it, that is not I, 4 I, but minus 4 I2 is equal to Vx, but from the equation 1, that is above equation Vx is equal to I1 minus I2, you substitute it, then you can find out the I1 is equal to minus 3 I2. So, once you find the I1 is equal to minus 3 I2, from the loop 2 and 3 also apply the KVL. Now, in this second next step, apply the KVL in the second loop or second mesh. Okay. So, I am starting at 4 I2. Okay, I am starting at the 4 ohm resistor. So, 4 I2 plus 2 into, now this case, so second loop is our reference loop, therefore, I2 is entering, so I1 is leaving, therefore, 2 into I2 minus I1. Okay, the second line 4 I2 plus 2 into I2 minus I1 plus the voltage drop in the 6 ohm resistor is I2 is entering and I3 is leaving, therefore, 6 into I2 minus I3 is equal to 0. And also next step is apply the Kirchhoff voltage law in the mesh 3. Okay. So, now this is the loop mesh 3 is the reference. So, 6 into I3 minus I2, in this case I3 is entering and I2 is leaving, therefore, 6 into I3 minus I2 plus 2 into I3, the voltage drop in this 2 ohm resistor plus 1 volt what we have applied equal to 0. So, solving these equations, now we have the 3 equations, one is called I1 is equal to minus 3 I2. So, here second equation and third equation. So, 3 equations, 3 unknowns, you can easily solve the equation, then you will get the I3 is equal to minus 1 by 6 amperes. But what is this I3? So, this I3 is opposite to this I0. See, I3 we have assumed at clockwise direction, but I0 is coming towards the upward direction. So, therefore, I0 is equal to the minus I3, which is equal to 1 by 6 amperes. So, minus into minus plus, minus of minus 1 by 6 is 1 by 6 amperes. Then what is the Thevenin resistance? So, R Thevenin's is equal to the 1 volt by I0. As I told you, so when you apply the 1 volt source, voltage by 1 volt by whatever you find the current I0, so 1 volt by I0 equal to 6 ohms. So, this is the Thevenin resistance. Okay. So, this is what the Thevenin resistance, sorry. Now, to get the V Thevenin's, now how to find out the Thevenin's voltage? To get the V Thevenin's, here also I am using the mesh analysis method. So, here 3 meshes are there, mesh 1, mesh 2, mesh 3. So, mesh 1, assume all the currents are in clockwise direction, I1, I2 and I3. Now, apply the Kirchhoff voltage law in the mesh 1, mesh 2 and mesh 3 respectively. So, here I1 is equal to 5 amperes directly, because I1 if 5 amperes is there, I1 is there. Now, next apply the Kirchhoff voltage law in the mesh 2. So, therefore, 2 Vx, okay, 2 Vx plus 2 into I3 minus I2 Okay, in the mesh 2, I3 minus I2 equal to 0. From this Vx is equal to I3 minus I2, you can get it. In the next one, 4 into I2 minus I1, okay, in the second loop, 4 into I2 minus I1 plus 2 into I2 minus I1 plus 6 I2 is equal to 0. Next, but 4 into I1 minus I2 is equal to Vx, because what is the voltage drop across the 4 ohm resistor? Vx is equal to, so current I1 is entering and I2 is leaving. So, I2 minus I1 is equal to 0, sorry, Vx. So, therefore, 12 IT, now substitute these equations, 12 I2 minus 4 I1 minus 2 I3 equal to 0. Therefore, I2 is equal to, if you solve this equation, then you will get I2 is equal to 10 by 3 amperes. Therefore, what is the Thevinen'S? So, Thevinen'S is the open circuit voltage, means the voltage drop across the 6 ohm resistor, that is 6 into I2. So, 6 into what is I2? 10 by 3, 3 1 the 3 2 the, so 2 into 10 is 20 volt. So, then we can easily draw the Thevenin equivalent circuit for the given network. So, what is the, see now what is the conclusion is, so this is the this is the circuit or network given. So, this entire network can be converted, we have converted into only this is the network. So, this is the Thevenin's voltage 20 volts in series with the resistance, that is the Thevenin resistance 6 ohms. This is the Thevenin equivalent circuit. Okay. Now, example 3. Now, this example dependent sources only case. So, case 3, if any network consisting of only dependent sources, okay, only dependent sources. Case 2 is independent and dependent. Independent we have to kill it, and here dependence. So, determine the Thevenin equivalent circuit as shown in figure. Now, here Thevenin's voltage is 0, because there is no active elements or there is no independent elements. So, the Thevenin's voltage is by default 0, because there is no active elements, no one is supplying. So, therefore, how we have to find out the RThevenin? See, RThevenin can be found by applying 1 volt voltage source or 1 ampere current source across the AB terminals, and we can find the Thevenin's resistance. Here I am using a nodal analysis to find out this Thevenin's resistance. See here. So, what are the currents coming to this circuit? See the second circuit. So, the currents coming to the entering currents equal to the leaving currents. So, current enterings are, so I naught and Ix are entering to the V naught node, and that equal to current, so 2 Ix, and the current flowing to the 4 ohm resistor is V naught by 4 are leaving. Therefore, I naught plus Ix is equal to 2 Ix plus V naught by 4. But what is Ix here? So, Ix is current flowing through the 2 ohm resistor, that is the, it is flowing from 0 to V naught. So, therefore, 0 minus V naught by 2. Okay, that is 0 minus V naught by 2, that is minus V naught by 2. Now, substitute this Ix value in this equation. So, you will get here I naught is equal to Ix plus V naught by R, because here 2 Ix minus Ix is Ix, there plus V naught by R is there. So, V naught by R is there. So, that is equal to Ix we have got minus V naught by 2, substitute it, plus V naught by 4, then you take the LCM, you will get the 4. So, minus 2 V naught plus V naught. So, V naught by 4, or V naught is equal to minus 4 into I naught. Thus, so RThevenin, so we applied the, okay, we applied the here V naught. So, what is the V naught? RThevenin is equal to V naught by I naught is, so minus 4 ohms. See here. So, V naught is equal to minus 4 into I naught. So, RThevenin is equal to V naught by I naught, that is minus 4 ohms. So, what is this minus indicate? This minus indicates it is supplying the power, which is supplying the power. It is not observing, it is supplying the power. That is what the today's lecture. So, let us see in the next lecture. Thank you.